All right, for back by popular demand, I'm going to do some more solving trigonometric equations where you have intervals of solution where you're only going from 0 to 2 pi. And these are some more crazy ones. This was like my example number 6, if you followed along. And went through all my videos. Example number 6 was where you had an equation with two different values. Now, when you have this, we're going to find the solution from 0 to 2 pi. From 0 to 2 pi. And to solve this by hand, we're going to do is a little algebra. So what we have right here is we have 2 sine squared of x equals 2 plus cosine of x. Now, whenever you solve these by hand, generally what we want to do is we want to try to put them in terms of the same variable. Okay, in this case, or the same trig ratio, I'd say. And you always want to set them equal to 0 if possible. Okay, unless you use your calculator. And we're going to, I think I'm going to try doing this using my calculator as well. And show you 2 different ways of how to solve this. All right, and then probably 2 different videos, but this is what we got right here. So to do this by hand, what we're going to do is I'm going to first subtract this and make it equal to 0. So what we have is 2, all right, sine squared of x. All right, I'm going to subtract 2 to the other side, and I'm going to subtract cosine of x to the other side as well. I'm going to set that equal to 0. So I just made this equal to 0. All right. Now, in my other video, we would always be able to factor out something. Well, we don't have anything to factor out, essentially. We have 1, 2, 3 different terms. We have a cosine and sine, and that doesn't work out. Now, this is where the fundamental trig identities come in, all right? Fundamental trig identities, all right? Now, if you recall, all right, we want to get something so we can factor, or at least simplify a little better. So what we're going to do is we're going to take this cosine. I notice I have sine squared. Sine squared, if you recall, there is an equation, sine squared of x plus cosine squared of x, and that's going to equal 1, correct? You remember that? Sine squared of x plus cosine squared of x equals 1. So I'm going to take and solve for sine squared, and sine squared of x is actually the same thing as 1 minus cosine squared of x. So what we're going to do is we're going to use this fundamental trig identity, and I'm going to substitute it in to this little expression right there. All right, you do a little substitution. All right, sub it in. So what we get then, I'm going to change a different color now. So now I have 2. All right, I'm going to substitute this in for here, because that's where sine is equal to, right? So now I'm going to have 1 minus cosine squared of x. All right, minus 2 minus cosine of x. And that's going to equal 0. Okay, so now from here, once I can do my substitution, now I have cosine and cosine. So now what we're going to do here is I'm going to now distribute through, and I'm going to have 2, all right, minus 2 cosine squared of x. So now we're simplifying this, all right, right here, like so. And from here now, we notice that we can cancel things out. Cancellation, remember? So 2 and negative 2 will cancel out. And now I'm left with is this, all right, negative 2 cosine squared of x minus the cosine of x equals 0. Now, just like we did in the past, if you were to have this, all right, and then we'd say y equals cosine of x, and we had then, if I would substitute that in there, negative 2, this would be y squared minus y equals 0. All right, how would you solve this algebraic expression? So I'm going to change something that is not familiar to something that is familiar, right? So let's say we have y equals cosine. Because like, if you don't understand trig, this is what I would kind of do to get the understanding a little bit. All right, so now I'm going to distribute out, well, what I would do is distribute out a negative y. So if I distribute out a negative y, all right, I'll then have 2, all right, y, and we'll have plus 1 here. And that's going to equal 0. And then from here, this is an algebraic expression where we know that, all right, negative y would have to equal 0, and that equals y equals 0 there, right? And then we would have another one where we have 2y plus 1 equals 0, and we know that y would have to equal at negative, all right, 1/2 right there, all right? So those would be our solutions if we just did it algebraically. Well, we do the same thing as this over here, all right? Y is cosine, so I could actually simply just put in cosine of x and for y in both of these, all right, and solve, all right? And I will do that, but just to show you how this works, what I can do is I can factor out a negative cosine of x. When I do that, I have 2 cosine of x, and that'll be plus 1. And you can see then, once again, we go through the same process. Negative cosine of x, that has to equal 0. Where does that equal 0? Well, I don't know that yet. But wherever cosine of x equals 0, because I can divide negative through, I know that cosine of x will equal 0 somewhere, and that goes by that right there. And then we also know that 2 cosine of x plus 1 has to equal 0 somewhere around here. So we can realize that when we solve this negative 2, so we'll have cosine of x equaling negative 1/2. And you can see that my substitution, if I would have done it, all right, I could have gotten my answers right there real quick. Okay, so now what are we looking for? We're looking for all solutions. Solutions mean all of the values, all right, when we solve this. And we're looking for when cosine equals 0, and then when cosine of x equals negative 1/2. All right, so from 0 to 2 pi, all right, not including pi because we have that parenthesis there. All right, so cosine of x equals 0, cosine x sine y. All right, that's what I always say to my students. All right, and we have cosine of x equals 0. Cosine is 0 where? It's going to be here, all right, because we got 0 and 1. So what is that? That is going to be 90 degrees, which is x is going to equal pi over 2. And then we also have it over right there, because at this point on the unit circle, it's going to be 0, negative 1, correct? And once again, cosine x sine y, and at x equaling 3 pi over 2. And that's what we have right there. Right? So cosine x equals 0 at pi over 2 and 3 pi over 2. All right, now, the next thing is cosine of x, where we have this one. Oh, and if you're wondering, yes, what we can do is we can solve this by just taking the inverse cosine. Now, when you do take the inverse cosine, just I don't know if I mentioned in my other videos, but you do have to use a little bit of trig sense, okay? Because when you punch this in here, remember that the range of inverse cosine only goes from, all right, 0 to pi. So you only get is one answer. You'll just get this answer right here, pi over 2 or 90 degrees, all right, depending if you use radians, all right, or 90 degrees. All right. Now the thing is that cosine of x is 0. So you have to, this is where you have to use your common sense. You have to understand your trig. Is that where does cosine of x equal 0? Yes, 90 degrees, but also right over here in the, all right, at 270 degrees. All right, and that's what you have to also understand. Okay. So make sure you understand your circle chart. Make sure you understand all the possible values. So using your calculator, that's why with these simple ones, it's better to just use your brain. Understand trig, okay, and then unit circle, and that helps you solve all these values a little bit faster, more efficient. Okay, now back to the other answers. So if I do the same thing here, all right, I want to figure this one out. So cosine of x, now we're going to go down here, and then where is that going to equal negative 1/2? Well, cosine, if I did this inverse cosine, all right, of negative 1/2, all right, because if I would solve that, I would equal x, all right. What I get would be, well, I would get one over here in the second quadrant, correct? And so if you did this in degrees, you realize that hopefully this is going to be negative 1. Cosine is adjacent, all right? Hypotenuse, I draw a little triangle right there. That's how I always remember this. And so what I have is this radical 3. Now the thing is that when you put this in here, it should equal, cosine is going to equal, I'm going to put this in green so we can see the difference, all right? What is this angle going to be? Well, this is going to be the reference angle is going to be a 60-degree angle. So subtract that from 180. And so this is going to equal, and 60 is pi over 3. And it's going to be here in the second quadrant. So 2/3 of a whole pi. Remember, pi equals 180 degrees. And that's what we have right there. All right, we don't need to add the coterminal values because we're only finding values between, all right, 0 and 2 pi, 0 and 2 pi. So that's our 1. However, we also know, and this is where to use your head, is that, yes, cosine is also negative, not only in the second quadrant, but is also negative in the third quadrant. So, yes, you have to use your trig values, and you have to know what those are. And so we have this. Once again, it's going to be 6 degrees. Now, this is negative square root, but it doesn't matter. All right, but we have 60. All right, so what is that going to be? Well, we have another value when we go all the way around the unit circle, go whoop, right there. All right, we're going to have to add 60 to 180, add 60 to 180. All right, and what we have is 240, right? All right, and so what is that going to be? Well, that's going to be 4 pi over 3, because that's 4/3 of, or 4 times 60 degrees. all right, which is 240 degrees, okay? And so what we have right here are, yes, all right, our two values. So we have 60, so this would be 120 degrees, or what we could have right here would be, all right, oops, I'm sorry, so okay, four times would be 240 degrees right there, all right, because we get to go past pi and add another in the third quadrant. So here's one in the first, here's one in, or not the first, but here's the 90 degrees, 270, and these are all of our values, all right, that we're looking for. These are all of our solutions to this problem. And that's how we would do it without our calculator. Once again, these are simple trig everyday problems. You have to understand those and how to solve for those, all right, when we're doing those. All right, well, that's our values. I'm going to show you how to solve this with your calculator in my next video. All right, good luck and God bless in the rest of your problems.